software projects I came across during my work, and I think also other people would benefit from knowing about these projects. So the first one is an introduction to SnakeMake, which is a workflow management program in a Pythonic style. And the second big project I want to talk about is Elephant, which is an analysis toolbox for electrophysiology data. And this project is based on NEO. So the latter part is completely on the Python side. So sorry for MATLAB users here. Okay, I guess workflow management is a topic not many people usually think about when starting working on the master thesis or on a PhD. So I just want to give you a short motivation on why this might be an interesting topic for you. Mm-hmm. So when you start working on a project, typically in the beginning everything looks easy and straightforward, but later it turns out that things are getting more complicated, and you have lots of scripts which you have to run in different orders to finally achieve your plot you want to publish at the end. And to keep track of this, how this plot was actually generated, documenting the workflow is a good way to do that. Then second point is, if you want to collaborate with other people and share the code, or even publish the code together with your plot, it's easier for the reviewers and for the readers of your paper if you provide a packaged workflow where everything is kind of documented in a way so that they can run it in an easy fashion, and that where versions of software packages you use are also well defined. And the third point is actually coming together with this. So software is evolving, and once your workflow is running today, if you install the same or install similar packages or later packages at another time point, this might change the result of your analysis. So if you package everything in one workflow and specify defined versions of programs you're using, this is also reproducible in the future. Okay, so let's start with the SnakeMake. So SnakeMake is a workflow management system. Those of you who know Make maybe from earlier times, this is very similar. It's kind of the same idea, just written in a more Pythonic way, and yeah, easier to handle, I would say. So for those of you who are not familiar with Make, so the way this works is you define your workflow in individual steps, and each step is defined by the files which are required to perform the steps and the files which are the actual output of the step. And then you, in this so-called rule, you define on how you go from the input files to the output files. So if you want to write this down in SnakeMake, the whole workflow can be described in a single snake file. So this, for SnakeMake to recognize the file, this file actually has to be called snakefile with a capital S. And in this snake file, I can then specify a rule on how to go from one set of files to another set of files. So in the simplest case, this would be a rule specified like this. And then because it's Python based, I have to indent now what content this rule has. And then I can specify the input. So meaning files which are essential for this rule to be executed. For example, I have a file A, a text file, and then as an output, I generate another file.
You want to switch your share screen to this one, or move the
I can.
binder up to the top?
Yes, I can move this one. So everything is described in this Jupyter notebook, but I'm doing this online now in a text editor. But you can also follow the steps in the Jupyter notebook. So also in the Jupyter notebook, I'm generating the snake file and just writing these couple of lines into the snake file. Okay, and now I just need to specify how exactly I go from the input files to the output files. And here I have multiple options. So I can tell SnakeMake that it can run this code in a shell. For example, in the simplest case, here I just copy file A to file B. Okay, so this would be already one complete rule in SnakeMake. So the smallest kind of workflow you can imagine. Now I want to save this. I have to find the right location. In the study group. Lessons. No. Lessons. Okay. So as I said, I have to name this snake file. Save.
So if you have different workflows, they all have the same name?
So typically one workflow lives in one folder or like subfolders, and you can have multiple snake files, and you can also import one snake file into another one, and then the rules are just merged. But so for now, this is just making things too complicated.
So you saved this into a directory?
Yeah.
Now
So
you
now
save
I
it.
have. Now I can show it to you. I have. Wait.
Yeah, the study group.
Yes, if I would be able to go there, I'm not able to go there. Why not?
Show us the save again.
Yes. So here I'm writing this into the snake file, and now if I want to execute this, I can show it here. So now I'm in this repository. There's the snake file I just generated, and if I now want to run this workflow, I just ask SnakeMake to do what it does. SnakeMake, and it's telling me so missing input exception. So what SnakeMake is trying to do now, it's reading the snake file, it's finding the first rule present in there, and it's trying to execute the rule. So
It looks for file data.txt.
Yes, and now it's giving me missing input exception in line 1. There's a file missing it, which is required for that rule.
You don't have such a file.
Because I don't have such a file, as you can see here. So I can generate such a file like this. Now there's a file A text file here, and now if I try to run the workflow again, like this, I don't get an error anymore, and
Yeah, we have a file b.txt.
yes, and I have a file b.txt, and you can already see how SnakeMake is structuring the output. So it's telling you, okay, so right now there's only one thing to be executed, and this is rule 1, which has this as input and output, and it's the only job, and it tells you, okay, 100% is done, so no errors in between. Okay, but if you write it like this, then of course your workflow is pretty hard-coded and not very Pythonic. So maybe let's first add a second rule to make the concept clear. So I'm removing this file A I just generated. So now it's gone, and I'm also removing the file B. Now this is gone. And let's add a rule which can generate a file A. So now I add another rule. And this has as an output now something called file A. It requires no input. And to generate this file A, I do the same as before. I just, in a shell, I just touch the file.
What's your text editor in Linux?
Yes.
If you're in Windows and you're using Notepad, you should say Notepad.
Yes. In Windows, it would be a bit different, but I'm not familiar with that.
What are the text editors?
Yeah, you can just generate an empty file in any.
But all the commands, all the rules are shell.
Yeah.
Rules, shell commands.
So right now, all of this will be executed in a shell.
Yeah.
You can also, in a later step, I will show you that there's more than just a shell command to define the content of a rule, but you can also run Python code directly. Yeah, but for now I'm sticking to this. And if we now run this, so I saved this file. If we now run this, you can see that there's now two jobs to be executed. The first one generating file A, and the second one generating file B based on file A.
And it doesn't matter that the rules are not in order?
The order doesn't matter. So what SnakeMake is doing is you can have 100 rules, only 3 of them relevant for your result, and it will find the ones which match, and then just in any means your rules can be used. It will try to generate that file you are asking for. You can also ask for files explicitly. So right now, SnakeMake is just looking at the first rule and trying to execute that one. But if this rule wouldn't be the first one, you can also just do SnakeMake file b.txt, and now it would try to generate file b. So right now it's telling me nothing needs to be done because I already have a file b, and I can do this also with other files. But then, of course, for file c, there's a missing rule exception. There's no rule. SnakeMake doesn't know how to generate this. Okay. So now that we have 2 rules, it might be interesting to look at how they depend on each other. If you implement more and more rules, at some point your workflow might be too complex to just follow it in your text file. So it would be nice to have a visualization. And SnakeMake can do this for you. So you can ask for a visualization for a directed acyclic graph. And if you just do it like this, you will get a kind of a text representation of that. And on Linux, you can just convert this to a plot using this display. Something popped up somewhere, I hope. Yes. Okay. So now you see the dependencies of the rules. So first, the second rule is executed, and then the first one, and then the workflow is done. And to make this more readable, we can also provide names to our rules. So I can call this one generate A, and this generate convert to B, and this one generate A, and then this graph will also be more telling. Here. So if you label your rules in a central manner, then you can actually read your graph at the end. Okay. You can also, so in case you are working with the online version of the Jupyter Notebook, then of course you won't have a pop-up window, but you can also look at the visualization, which is generated by just saving it as an SVG, and I can show this, or in any other format, and I can show this here. So in this line, this is basically the same as before, just now dot is not directly displayed, but it's saving the result into an SVG file. Okay. As I said before, so now the workflow is pretty hard-coded. So we have explicit file names in this workflow, which is not really Pythonic. So we can make this more flexible. I can use so-called wildcards in here. So I can make rules more flexible by making, for example, the file name, define this in a more general way. So for example, this is now not file B, but it can be file and then any ID, anything which matches in there. And this is now called the wildcard. And depending on which file I ask SnakeMake to generate, this ID will have a different value later. And I can also now use this in the input, but to make these files now not identical, I have to use subfolders. So I call this original data and this one new data. Otherwise, the files would be identical, just to make these files different. And
what is the /?
This is just on Linux, go to a subfolder, like a.
So why do you need to make a folder? Why don't you make new?
File name? Right now, I just want to use the same value of ID. I can also call this now tada ID. This would also work.
Yeah, I understand that. And file was fine, but I'm saying why not have a underscore instead of /? Like the new data that you wrote?
That also works, yes. I just want to mention here that if you're working with folders, then SnakeMake, and your rule requires a subfolder, then SnakeMake also generates the subfolder if it's not present already.
Okay.
So that's also a nice feature that you don't need to take care of. Okay, are all the folders already existing and all of that? So it's helping with that in that sense.
Okay, let's do it with folders.
Okay, so original data file and new data. Okay. And then, of course, I also need to adjust this. And here I can also use the same mechanism as before. So instead of defining this now hard-coded, I can actually use wildcards. But in this case, not the ID wildcard, but I can use the input and output. Input and output. And this will then be substituted whenever this rule is required to be executed. So this input will have that value. You can also have, of course, not only a single file as an input, but multiple files. So you could kind of add more content here, more files. more files. But just be aware that you need to separate them with a comma, otherwise you will run into errors. That's one of the things you shouldn't forget here. And then input would also be a list of files. One of the Python aspects of this is that you can then also provide names for this. So you can kind of build a dictionary. You can call this second input and do it like this, and then refer to this one as second input. And this would be then only this file. Okay.
You have this in the notebook.
I think so. I think keywords I didn't cover, but so anyway, the SnakeMake documentation is pretty extensive, and also the list of frequently asked questions is kind of detailed. So if you're looking for, if you're coding a SnakeMake workflow and are stuck somewhere, probably someone asked this question already. So the documentation is really helpful here. Okay. Of course, now I also need to adjust this. And I can also substitute this now as output. Okay. Now let's try to, sorry, wrong one. Let's try to run this. Now I'm trying to generate the new data file A. And you can see each rule is executed once. And the important part here is now that also the current values of the wildcards are shown here. So for the convert rule, so this one, where the ID is a wildcard, SnakeMake tells you, okay, for this execution, this wildcard ID has the value A, because I was asking for file A. And now the workflow is flexible enough to do the same also with file Z. Should be. No, I can only generate a file A here. Okay. So now convert to B would be able to handle a file called file Z because ID is flexible, but then there's no rule which can actually generate the original file here because the other rule can only generate file A.
Or do it wildcard then. Make it to convert it to wildcard.
Yeah. Okay, so save. Yes. So now you can see I have the ID Z here and the ID Z here, and now this works. Okay. So this is still a pretty linear workflow. In reality, workflows are a bit more tangled. But always having, so when implementing the workflow, always having a look at this graphical representation of the workflow really helps in knowing what you're actually coding and how SnakeMake would interpret this. Because especially in the beginning, with this kind of backward way of thinking, okay, we are starting at the output files, and then SnakeMake is going back and looking for the corresponding input files. So this is something you definitely need to get used to, because at least I tend to think in the other way. So I have these input files and then want to generate something from that. But if you keep that in mind, this should make it easier. Okay, so now, how much time do I still have?
7 minutes.
10 minutes?
More than 10 minutes. Yeah.
Oh, it's only the beginning. Okay, then maybe I skip the following SnakeMake part and rather talk a little bit about Elephant, even though I won't be able to show a lot of content there. So
No, you finished the SnakeMake. It's fine. No?
sure. Okay, maybe I just.
We can also go 10 minutes over because
Okay. Maybe I just mention some of the kind of advanced SnakeMake features, which I find fascinating. So that even more reasons to use SnakeMake. So as I mentioned already, instead of writing shell here, you can also, if you have a Python code, you can also just call run and then provide a kind of a Python script here, which then will be directly executed in a Python environment. And the fancy part about this is SnakeMake integrates nicely with Conda. So this is what I was talking earlier about. You specify in which environment your workflow should be running. So you can specify a Conda environment via a requirements file. So sorry. So for example, like this. So this would mean I need to, of course, generate this file and have the right layout in this. So, but I guess everybody knows how a requirements file usually looks like. So specifying Python version and everything else which I need for this step of the workflow. And this I could in theory do for each individual rule differently. Meaning if parts of my workflow are depending on very different versions of NumPy, for example, I can still have it consistent in a single workflow by having different requirements files. So like having one here and having another one up there. So this is one nice thing. But then if you run Conda with this, you need, if you run SnakeMake with this, you need to tell SnakeMake explicitly that it should use Conda. So that's why you have to run SnakeMake using the -- use Conda flag. Of course, for debugging, having a dry run version of the workflow execution is also always good. So you can have this with a dry run flag. If you are debugging your workflow and want to have a look at what shell commands SnakeMake would actually run, you can also have a printout of this. I already mentioned the kind of distributed SnakeMake files, so you can include one SnakeMake file in another one. Configuration files is always important, especially when you are sharing workflow with other people. And you want to specify, okay, my data is located here, but another person has data located somewhere else. SnakeMake then allows to have a config file in the beginning. So this would be similar to config file, and then you provide the name of the file here. Yeah, I only showed the directed acyclic graph. So the visualization you saw earlier. If you have lots of scripts or lots of rules which are executed like 100 times with different wildcards, for example, of course, this type of graph can become really messy. And to kind of ignore different wildcards and just visualize how the individual rules in your workflow depend on each other, there's also, instead of the -- -DAG, you can also ask for the the rule graph, which would then be a much simpler graph, just showing dependencies of the individual rules of your workflow. And if you're working with remote files, so having files somewhere else, for example, on Dropbox, SnakeMake is also able to handle that and to check out the right files when it's needed, and to not have everything on disk at once. Yes, and of course, have a look at the SnakeMake documentation and the frequently asked questions. Okay, with this, I would move to the next part. So Elephant is now only for the people using Python. There's no reference implementation in MATLAB. And Elephant is an analysis toolbox for electrophysiology data. It is focusing on the analysis of spike train and local field potential data. And the main focus, or kind of the really detailed methods in there, are methods for detecting higher order correlation in spike trains. So, for example, if you have recordings from 100 neurons in parallel and want to detect kind of patterns of activation in there. Okay, so Elephant has itself no visualization or no graphical user interface, so it's a purely script-based analysis you are performing with Elephant, and it's based on a specific data model, which is called NEO. So NEO is a project which aims at kind of providing convergent or the tools to load data coming from a number of different proprietary and non-proprietary formats, and kind of display this in a generic framework. So NEO itself, it's not a file format, but it's only the in-memory representation of the data. And you can see here kind of a rough overview of what NEO can handle. So the main objects here are spike trains, of course, which is then representing a time point series, and analog signal, meaning continuously recorded data. And coming with this, also waveforms of individual spikes and a number of additional objects which are marking specific times in your recording, for example, trials or events in your recording. And all of this, kind of the logic between these signals I just mentioned, is then handled by so-called container objects like a channel index or a segment, which is then linking to multiple of these previously mentioned data objects. And NEO is doing this in a rather generic way. So the actual meaning of the objects for your specific experiment is not coded in the data model, but you can use annotations for doing so. So whether an epoch now is marking an individual trial in your experiment or just the first 10 seconds of your recording, this is up to you, and you can specify this using this generic annotation mechanism, where you can just provide kind of a dictionary for each object, telling, okay, I'm naming this like this, like first 10 seconds recording, and then you know what you're talking about, but the data model behind this is always the same. So this is a overview of the different formats NEO is interfacing with. So you can see it's quite a number. The ones which are touched in this notebook is like BlackRock file formats up here, and Nix, the Nix file format down here. So BlackRock is a proprietary format, and Nix is an open source generic data framework for representing any type of data, not even limited to electrophysiology, but really kind of any type of data. And the advantage of using Nix here is that it can handle, or it stores data together with the corresponding metadata in a single file. So it's kind of a container where you can save your experimental data from the raw recording signals, but everything describing these raw signals in addition to, and you can draw links between the two. Okay, so this is a sketch of how the NEO classes relate to each other. I think I'm not going into the details here. So in the notebook, what you can have a look at if you have a bit more time is an example on how Elephant can be used to generate artificial data. So all of these complex higher order detecting algorithms in Elephant, of course, need to be tested on ground truth data. So Elephant also has a battery of methods to generate artificial data to test your analysis methods. And in the beginning, I'm showing on how this can be done by generating spike trains with a known correlation structure.
But we can't plot it?
I think I did. So down here, so this is an example of one of the sets of spike trains which are generated, and you can see, okay, this is Poisson data, but in the bottom 10 spike trains, you see, okay, there's correlated activity. And of course, now in this plot, you actually see that there's correlated activity, but if the IDs of the spike trains would be shuffled, then you wouldn't see these lines anymore. And that then makes it obvious why you need methods to detect these correlations. So the SNACMake workflow in there actually generates 10 sets of artificial data with correlated activity in here, like this, and then runs an algorithm which is called SPADE, which is detecting spatial temporal patterns in spiking activity. So this is then working on a list of NEO spike train objects, detects these higher order correlations and also calculates or estimates the significance of these correlations. And as a result, these can then be visualized. So in the artificial data, these correlations would be detected, and if you go to the bottom, you can see that this can also be run on experimental data, whereas here the experimental data are coming from a data publication, and the data is hosted on the platform called Gin, which is kind of a merge between Git and Git Annex, and it's used for hosting of large data sets, including version control. And you can also use it, as you see here, for publishing data. So there's a service to generate a DOI for data sets.
Can anyone subscribe to this platform? Can anyone subscribe?
Yes, you can. So this particular server where the data is hosted, this is provided by the developers of this, and it's developed by the German Neuroinformatics Node, which is sitting in Munich. But in itself, the whole system is also open source available, and you can also set up a server in your own lab if you want to and just use it locally. Okay, so what at the end of the SnakeMake workflow is happening? So I'm adding rules which are fetching the data from the server, and then running the same rules on the experimental data as the ones I used before for the artificial data. And then at the very end, you can see the detected patterns of spiking activity in the experimental data. Okay, so I'm sorry I haven't had time to to go through the details of this due to technical complications. Yeah. In principle, you should be able to just click through the whole notebook and run each cell on your own. And I hope the description is detailed enough to make sense of that. Yeah, if not, then you can still raise an issue or ask questions in any other means to this notebook. Okay, thank you.
Thank you.